In this video, we're going to discuss changes of state. So there are three main states of matter that we deal with on an everyday basis. And those would be solid, liquid, and gas. And these depend on how much energy the molecules have. Gas particles, in general, have high energy, whereas solid particles generally have low energy. The transitions between solid, liquid, and gas have different names. So if I'm going from a solid to a liquid, we're fairly familiar with that. That one's melting. If we go straight from a solid to a gas, however, that is called sublimation. Going from a liquid to a solid is melting. Again, a very common phrase. However, again, when we're going from gas to a solid, that's called deposition. And deposition is commonly used in the semiconductor industry to make wire type structures on chips. So why do chemicals change state? So if we have a solid, in a solid, let's say that we have this in a beaker of some sort. In a solid, we have very rigid spacing between the particles of the compound. They have to stay in place, but they will vibrate slightly where they are. And so in actuality, instead of just sitting in one place, these molecules will vibrate in place around where they're staying. And when they start vibrating hard enough, the intermolecular forces that are holding these particles or molecules of the compound together will start to break up and break apart, and then we will end up with a liquid state in which the particles are spaced out, generally a little bit more. Again, ice would be the exception to this rule, that ice is actually less dense than water, which means for the same amount of mass, the particles are more spread out. And here, when we have this kind of situation, our molecules are moving much faster in the liquid setup than they are in the solid setup. And so they actually will have trajectories where they're moving quite a bit around the container. And eventually you will have some particles that when you heat it up, again, heat is kinetic energy, so it's the energy of movement. And as you heat up the particles in a container, they will start to move more and more quickly. And occasionally, one will get out. And so if you have this container of liquid, there will be some gas particles that will form from the compound. There's also going to be air particles that are going to be also here. And some of those particles will end up moving again, and this will become sort of like a game of whack-a-mole. So when you have whack-a-mole, this is a game where you have these little rodents, and the rodents will stick their head up out of the holes, and then there are hammers, and the hammers will bang down on the surface of the moles' heads in such a way that they push the moles back down under the surface of the ground. And so we can think of this as a game of whack-a-mole where the air particles or gas particles are the hammer and the liquid particles are the moles. And so as these moles try and come up out of the surface, if they are hit on the head, then they will change their trajectory and go back down underneath the surface of the liquid. And so two things can raise the boiling point or make it harder for these liquid particles to come out of the liquid. The first thing would be number of gas particles, and the second thing would be the force with which they hit. These two things together are called pressure. Pressure is the force per unit area. And basically, there's two ways that you can increase the force on the surface of the liquid. And the first one is to increase the number of particles hitting it. The second one is to have those particles hitting the surface harder. That means that the higher the pressure, the more energy required to turn the liquid into gas, or the higher the boiling point of the liquid. In that reverse instance, the lower the pressure, the lower the boiling point of the liquid. So water generally boils at 212 degrees Fahrenheit or 100 degrees Celsius. However, if I take my pot of water that I'm trying to make tea out of, and I take it to 5,000 or 6,000 feet in altitude to the top of a mountain, the boiling point of water will go down by a couple degrees because as you go up in altitude, the air pressure goes down. And because the air pressure is lower, that means that there are significantly fewer particles colliding with the surface of the water that I'm trying to boil. And so I don't have to put as much energy in, which means it will boil at a lower temperature. Here is the review question for this video. Please pause the video, answer the question. So in this case, the boiling point of the water in the pressure cooker will go up. So the boiling point increases because of the increased pressure. And this allows us to cook at higher heat and thus more quickly. Again, the answer is the boiling point of the water increases.